Hi, I am Dr. John Bergdorf. In this video, we're going to explore the geometric concept of reflection symmetry. And I have the definition here for you to look at. A two-dimensional figure has reflection symmetry if there is a line that the figure can be folded over so that one half matches the other half exactly. The line is called a line of symmetry. Let's explore this concept with a couple of figures that I've drawn here, two stars that I want to look at, and we want to see if we can see reflection symmetry, and if so, where the lines of symmetry are. One of the best ways to explore this, and a great way for young people in elementary school classrooms to explore this concept, is by using some tracing paper to trace the figure and get a copy of the figure that it really is easy to fold. So what I'm going to do is I'm going to start with the star on the top, and I'm going to carefully trace over it as best I can. The noise you hear in the background is my cat playing with her toy. My apologies for that. She's having an awfully good time though. So we're tracing over this figure just very carefully. All right. And then we'll be able to look at it much better. All right, one more line and we'll have the whole thing. Now we're going to work with the tracing paper, although eventually I'm going to draw the lines of symmetry on my original paper as well. Let's get that out of the way a little bit, and let's take a look at this drawing. So tracing paper is very easy to fold, and I think you can probably already see there's some easy ways that I could fold this so it would fold exactly onto itself. And I'm going to literally make those folds and try to show you on the tracing paper that the figure does fold exactly onto itself if I were to fold it like this. That would be then a line of symmetry in this figure, and that would prove that we have reflection symmetry. I'm going to draw it like this, just dashed lines going across the center where I had that fold. Wonder if we can see another way we could fold this. Well, if it folds horizontally from point to point, I bet we could do the same thing if we fold it vertically onto itself. Let's see if we can do that. Yep, that's going to be no problem. And you can see, if you look carefully at the paper, that it folds exactly onto itself. And that gives you another line of symmetry. So we'll draw that one as well. And you might think, well, that's probably about it. Up and down and left to right, two lines of symmetry. But I wonder, can you see any others? I believe you can. The one that may not be quite as obvious is if you folded between adjacent interior points, like this perhaps. It would again fold. I'm going to do that perfectly. Let me try to do that a little better. It will fold exactly onto itself. Just a little bit. Yeah, that's a little better. And look again, that folds onto itself. Exact copy. So there's another line of symmetry that goes from here to here. Oops. There you go, like that. And I guess if that makes sense, then it probably makes sense that if I fold it from here to here, that would be another line of symmetry. And it would again fold exactly onto itself if I fold it that way. So I'm going to struggle with that a little bit. Have it go from corner, corner again. And it folds onto itself through those corners. I didn't get that perfect, but I think you see the point there. My other line of symmetry would go like this. So using the tracing paper and folding onto itself makes it very clear where the lines of symmetry in that figure are, and it does indeed have reflection symmetry. Let's just copy those onto this picture where it'll be a little bit easier to see. There's a line of symmetry that goes left to right. There's a line of symmetry that goes top to bottom. There are lines of symmetry that go diagonally this way and this way. Notice that all these lines of symmetry are crossing in a single point in the dead center of the figure, like that. Let's see what happens when we look at this other star. So again, I'm going to take my tracing paper and trace over it. Oh, that didn't actually make a mark. The shadow you now see is another one of my cats walking across the camera. Field of vision. We're having a lot of help here today. So we go all the way around this star as well. Okay, Thomas, your help is not required. Okay. Always wants to be part of the action. I'm afraid you're going to see a little bit of a tail coming through here. We trace the star carefully all the way around the edge. And then we're going to see how we can fold this to look and see about any reflection symmetry that we have. Okay, Thomas, you're a big help. Thank you. So let's look at this. We're going to have Thomas helping us out, I'm afraid. So if I take this star, I think you could see if I were to fold it, let me get rid of that for a second. If I were to fold it from the top to right here, it would fold upon itself. So I'm folding this tracing paper so I can look through and see that it indeed folds exactly onto itself. So there's a line of symmetry from the top to that middle point. On this one, I bet you can get the idea that the same thing would happen if you started any other point. Just turn this. If I write a line from here to here and fold along that line, I'll also have symmetry. Picture will fold onto itself. So you can see folding onto itself. So there's another line of symmetry from here to here. And similarly, there'll be lines of symmetry through each other point of that star. So let's write that on our final picture here. Okay, now we got a little fight going on. Sorry for all the extra entertainment on this one. Lines of symmetry go from here to here, here to here. Here to here. Here to here. And here to here. And notice once again that all these lines of symmetry are going to cross in the dead center of the figure. Lines upon which, if you fold the figure along those lines, it folds exactly onto itself. So I hope that is helpful. And my apologies for the guest cameo appearances during the middle of this presentation.